Hey, how's it going? Derek here with the next video in my Swift Basics series. Last time, we laid the groundwork by declaring and assigning variable and constant properties, reassigning the value of variable properties, and combining properties of the same or different types using concatenation, casting, and string interpolation. This video is all about operators and control flow in Swift. I'll go into arithmetic operators, which we already saw but didn't discuss. We'll explore logical, comparison, and compound assignment operators, and we'll learn how control flow works in Swift. Now, before moving on, I'd like to make a correction for the last video. I confused the names for backslash and forward slash. This is a backslash, and this is a forward slash. I used the correct characters on screen, so if you were following along, your code should work just fine. Now, with that out of the way, let's get started. So I have my playground here from the last video, and if we take a look at these 4 lines here, we can see 5 operators that we've already learned. So let's give them names. So we can start out here with the equal sign, which is the assignment operator. So we have our property name on the left side and the value we want to set to it on the right side. Next up, we have the plus operator, which we know is used for string concatenation and for addition. Then we have the minus sign for subtraction, the asterisk for multiplication, and the forward slash for division. So the next operator I want to take a look at is called the modulo operator. So that's represented by the percent sign. So the modulo returns a remainder from a division. So for example, if we type let remainder equals 35 modulo 10, we can see that we're going to get a remainder of 5 once this runs, because 35 divides by 10 evenly 3 times with a remainder left over of 5. All right, and now that this loaded, we can see that we do get that 5. So one example where this is going to be useful later is being able to tell odd from even numbers. So any number that's divided by 2 will have a remainder of 1 if it's odd, and a remainder of 0 if it's even, since even numbers divide evenly by 2. So we'll use this in a bit when we explore control flow. Now let's take a look at logical operators. The first one we'll take a look at is the exclamation mark, which negates a Boolean value. For example, if I create a new variable called not true and assign that value to true, if we run, we'll see that not true, we set to true, it's a Boolean value. So if we do our option click on it, we'll see that it is a Boolean value, and it's set to a value of true. Now if I come over here and type an exclamation mark in front of true and run this again, we'll see that the value is now false because we're negating true. All right, so that's our negation operator. So next up we have 2 other operators. We have a double percent sign for and then we have a double pipe for or. So we place these operators between 2 conditions, and we use logic to evaluate the 2 conditions and return either true or false. So let's take a look at these 2 truth tables that I have set up here. So we could see and operations and or operations here. So if we have a value that's true, and we're comparing it against another value that's true, we're going to get a true back. But for and, both conditions have to be true in order for it completely to be true. So if we have a false value and a true value, that's going to be false. I'm representing that here as not true. And then if we have 2 falses, we again get false, because we need both things in an and comparison to be true in order for the whole comparison to be true. Now for or, it's a little different. So we do have the same one from and, so true and true gives us true. But false and true gives us true because it's or. So either one of them can be true for it to be true. But if both of them are false, then we get false as the return. So that's the difference between and or. All right, so let's take a look at comparison operators then. Let's give ourselves some room here. We can form conditions with them that we can evaluate with our logical operators. First, we have double equal sign, which compares both values and returns true if both values are equal. It's important to remember that 1 equals is the assignment operator, and 2 equals is an equality comparison. So in my head, when I type double equals, I say is equals as a way of reminding myself that I'm comparing things. So just like with concatenation and arithmetic, both values need to be of the same type in order to be compared. We can compare two strings, and if each string is the same, we get true. But we can't compare a string and an int. So the opposite of equals equals or is equals is not equals or exclamation mark equals. This compares two values and returns true if the two values are not equal. Hence I read this operator as not equal. Rounding out our comparison operators, we have less than or equal to, greater than, and greater than or equals to. So these work as they sound. Less than compares two values and returns true if the value on the left is less than or not equal to the value on the right. Less than or equals does the same but also returns true if the values are equal. And greater than or equals are just the reverse of that. So through the magic of YouTube, I've gone ahead and put these as comments here, so we have these to reference. We have a couple more operators to learn, but first, let's use what we know so far and go through our first control flow, an if-else statement. So an if-else statement evaluates a condition and returns some code if it's true, and a different block of code if it's false. So we can take our favorite number from before, so let's take a look at that. We have our variable defined here. We set it to a value of 8, and then we set it to a value of 2. All right, so let's keep that in mind. Scroll back down here. So we start by typing if, then our condition we want to check. Let's do favorite number is equal to 2. Then we open a curly brace and type enter. Xcode will add the closing brace for us. So inside here, we can print favorite number is equal to 2, equal. So if we run this here, we know that favorite number is equal to 2, so we should get this back, and we do. Favorite number is equal to 2. So what if we reassign favorite number to another value, like 5? So let's do that. So let's say favorite number equals 5. And we run that again. Now we don't get anything because our favorite number doesn't equal 2. So if our favorite number doesn't equal 2, we need something else, which is our else. So we type in else just like we did with if and open a curly bracket. And inside of here, we can print out favorite number is not equal to 2. And if we run that, now we can see we get the code from our else block. Now let's leave this reassignment and change our is equals to not equals. If we run that again, we're going to get this because we didn't change the print statement, and it says favorite number is equal to 2. We can see how this inverts the condition, so we get a different result. We could also do the same with our other operators. So we know that 5 is greater than 2, so if we say greater than 2, we'll change this to greater than 2. And do the same down here. Okay, we can see favorite number is greater than 2. So what if we said greater than 5? Okay, we get favorite number is not greater than, well, 2. But if we change this to greater than or equal to, and run this again, we'll see we get the if block here, because it is greater than or equal to 5. Now let's throw in our logical operators. Let's create a couple variables first. First, we'll have ice cream scoops, if I could spell today, ice cream scoops. And we'll set that equal to 1 for now. And then we'll have another variable, we'll call that cherries, and we'll set that equal to 3. So we can use an if-else statement to compare the number of ice cream scoops and the number of cherries and print out a string. So let's start with if ice cream scoops is greater than 2. And now we're going to use our AND operator. And now we're also going to say cherries is equal to 4. All right, so what we're saying here is to return true if the number of ice cream scoops is greater than 2, and also if the number of cherries is equal to 4. So we'll open our curly brace. And in here, we're going to print. Now that's more like it. And for our else block, we will print out not what I want. All right, we can see here I forgot some parentheses, so I just got to add that in here. All right, so let's move this up a little bit, and if we go ahead and run this, we'll see that since ice cream scoops is 1 and not greater than 2, and cherries is 3 and not equal to 4, we get not what I want. So let's change the number of scoops to 4. So if we run this again, even though the number of ice cream scoops is greater than 2, we still only have 3 cherries, so we get not what I want. So now if we come over here and we change the number of cherries to 4 and run this one more time, we're going to get that's more like it, which I misspelled. So we'll change that. So we can add even more scoops. So if we say 6 scoops of ice cream, we're still going to get now that's more like it, because all we're saying here is we want the value of ice cream scoops to be greater than 2. So any value that's greater than 2 satisfies this condition, and cherries equals 4. So since both of these conditions are true, this resolves to true. And that's why we get this if statement. All right, so let's say you're just a cherry fiend, and it doesn't really matter to you how many scoops of ice cream there are. So we could change this from and to or. So let's set this ice cream scoops back to 1. So the ice cream scoops will now no longer be greater than 2, but cherries will be equal to 4. So if we run this, we're still going to get, now that's more like it, because in an or comparison, either one of these can be true in order for the whole thing to be true. So if both of these were false, so if we set cherries back to 3 and run this again, now both of these are false and we get the else print statement here. We could take this one step further with an if, else statement. So let's start a new if, and this time we're going to say if ice cream scoops is less than or equal to 2, we're going to print out it's good. Now we have our new else if. So this is a new condition that's going to be evaluated after ice cream scoops less than or equal to 2. So this time we're going to say if ice cream scoops are greater than 2, and we want ice cream scoops which are going to be less than or equal to 5. All right, so what this is saying is that any ice cream scoops that are greater than 2 and ice cream scoops that are less than or equal to 5, we're going to print out it's better. So this is going to cover ice cream scoops that are 3, 4, or 5, because it includes 5. And anything that's greater than 5, we're going to print out that's a lot of ice cream. All right, so let's set this ice cream scoops to 1, run that. And we're going to get it's good because ice cream scoops is less than or equal to 2. So we can do this for different numbers like 2, we get it's good, but if we do 3, we're going to get it's better. And the same thing for 4. And the same thing for 5. Okay, but once we change that to 6, we're going to see we get that's a lot of ice cream. So we can see here in an if, else statement, it evaluates if first, and if the condition is true, it runs what's inside of that block. If it doesn't, and it's false, it moves on to the else if. And if that's true, this gets run. And if none of those are true, it falls through to the else. You can have as many else if statements as you want. You just need to keep in mind that each condition will be evaluated in order. And the longer this gets, the more convoluted it can become and harder to debug. Instead of chaining else if statements together, there's a more elegant solution we can use called a switch. But before we dive into switches, I want to highlight a few more operators. The first is called a ternary operator. And you can think of it kind of like a mini if-else statement. So let's come down here and write a simple else statement. We can say if ice cream scoops is greater than 1, then we're going to print out enough, else print out not enough. All right, so if we run that right now, ice cream scoops is 6, so we get enough. If we change this to 1, we'll see that we get not enough because ice cream scoops is not greater than 1. But we can use the ternary operator to simplify this, and that's the question mark. So another way we could do this, instead of doing this whole if statement here, let's just do a print statement. We're going to say enough here. So if we print that out, that's going to just say enough because that's what we told it to do. But what we can do here is we can specify a condition and use our ternary operator to get a true-false result. So let's put our condition, ice cream scoops greater than 1, and then we place a question mark. And what comes after the question mark is what we want if this is true, and then after it we use a colon and we specify what we want if it's not true. All right, so what this is saying is basically this in a compact form. If ice cream scoops is greater than 1, then do enough, else not enough. So if we run that now, we can see we get not enough because ice cream scoops we set back to 1, but if we set that to 6, 6 is greater than 1, so we get enough. All right, so this ternary operator allows us to create simple if-else statements in a compact way that'll save us time in our code. The next type of operator we have is the compound assignment operator. It's easier to show you what these do. So let's say we have an int, it's a variable, and we're going to call it count, and let's set it to 0. All right, so let's say we wanted to increase this value. One way we could do that is we could say that count is equal to count plus 1. Okay, and if we print out count, we can see our count is now 1 because we've added 1 to count. So a simpler way to do this, if we're just adding value to the value itself and returning that value, what we could do is we could say count plus equals 1. And now if we print out count again after that, we'll see that now count is equal to 2. Now this works for subtraction as well. So if I come here and take out this plus and put a minus equals, we can now see that count equals 0 because we increased it to 1 and then we decreased it by 1. The last operator I want to mention before we head into switches is what's called Nil Coalescing. So if you followed in the last video, you'll recall that when we tried to cast a string into an integer that didn't contain text that could be cast into an integer, the value that was set was nil. And I explained that nil is an empty value. So if we have a string whose value is initialized as empty, the string has a valid value, even though it's an empty string with no value. So if the reference exists, but there's no data there, this is an empty reference. So this can cause issues in your code, which at worst can cause your app to crash or become unresponsive. So let's take another look again at casting a string into an integer. So let's say we create a property. We're going to call it string, and we'll give it a value of 4, a string value of 4. Okay, we're going to create another one called int from string, and we're going to cast that as an integer of string. So if we run this here, we can see we get an integer back that's 4 from this string. So that's just what we want. But let's change this string to 4D and run that again. And then we'll see that we get this nil. So instead of leaving this and causing potential errors in the rest of the code, what we can do is use nil coalescing to provide a default value in case we get a nil back. So over here, we do a double question mark, and then we just provide an integer value because we're expecting an integer back. So this time, if we run this, we'll see that instead of getting that nil, we get this 0. This isn't the only way to guard against null references, but it's efficient and good for many use cases. Last but certainly not least, let's dive into switches. So what we're going to do here is we're going to create a switch. So what we're going to do is we're going to create a string, and we're going to call it favorite color. And we're going to set that to be blue. Now one thing we could do is we could certainly do our if statements from before. So if we say if favorite color is equal to blue, we can print out favorite color is blue. And then we could do else if favorite color is equal to red. Well, then we could just copy this print statement and change this to red. And then let's do one more color. We'll do else if favorite color is equal to green. Well, then we can print out favorite color is green. All right, so if we run this here, we're gonna, just like we've seen before, we can get that, and then we can also do an else here, and we could say print unknown favorite color. All right, so if it's blue, we get blue. If it's red, we run this, and we get favorite color is red. And then if we change it to green, you'll see that we get green. All right, but if we put in another color like yellow, run that, and then we're going to get this unknown favorite color or favorite color. All right, so that works, but like I said, you can keep adding these else statements, and this can get kind of convoluted. So a more elegant way that we could do that is by using a switch. So we start with our switch keyword, and we say favorite color, and we open a curly brace. So switches have cases that they loop through. So first we'll say case blue. All right, so it's going to evaluate this favorite color string, and if blue is the result, then we're going to tell it that we're going to print out this print statement here. Okay, and then we're going to do another case for red. And then another case for green. All right, so actually this has to be a string green. So what you can see here is we're getting this error message, switch must be exhaustive. And what that means is that there has to be at least one value that's true. So because this is a string and there's an infinite number of string values that could be possible, there's no way that this switch could be completely exhaustive. So what we have to do is we have to provide a default value. So if all of these, not default, if all of these turn out to be false, then it's going to give us this. So then this is where we could just put our unknown favorite color. All right, and if we run this, we can see we basically get the same result back, unknown favorite color, because we're switching over favorite color and it has a value that doesn't match one of these cases. So we get the default. Now there are cases where you may switch over something that is a fixed collection of values, like an enumeration, and we'll cover that soon in another video. In these cases, Swift knows that there's a fixed set of possible cases, and as long as you give each of those cases, you don't have to provide a default. With that said, I find it good practice to always include a default, since it can be helpful for debugging if something weird and unexpected is happening in your code. Understanding these operators and control flow tools we have will help you create clean, concise logic in your apps. Today you've learned different types of operators in Swift and how to combine them to drive the logic in your apps with control flow. I encourage you to keep practicing and build your own control flow statements. If you have any questions on what we covered in this video, drop them in the comments below. Don't forget to like, subscribe, and hit that bell to make sure you don't miss the next video where we'll be exploring functions and closures. Happy coding!